Let's consider an example dealing with average acceleration. So our situation is we have a soccer ball initially traveling 8.9 meters per second towards you. I'm going to start with a diagram on this one. So if we diagram U, and here's the soccer ball traveling at 8.9 meters per second towards you. Now in part A, if you trap the ball, it stops in 0.2 seconds. So the ball gets to here, you trap it, it stops. So in terms of what we know, initial velocity 8.9 meters per second. By the way we've drawn that, that would be towards the right. Final velocity, it stops, that would be 0. And then time period, it takes 0.22 seconds to be able to stop. So then in part A, we want to calculate what the average acceleration is. So I'm going to write out the equation. Acceleration, change in velocity over change in time. So then plugging in our values, change in velocity, that would be final minus initial. Your final velocity is 0 minus the initial, 8.9 meters per second, divided by the time period, 0.22 seconds. If we calculate, we get a value of negative 44.5 meters per second squared. Now we have to interpret that negative. Positives and negatives mean different signs. And so when we started out, we had the ball traveling to the right, and we use that value as a positive. So in positive values would indicate to the right. If we're stopping the ball, we have to go against the velocity, or the acceleration would be a negative. So that negative means left. So then properly stating our answer, 44.5 meters per second squared to the left would be our acceleration. Now on part B, suppose instead you kick the ball in the direction it came at 10.3 meters per second. So now we're going to change things a little bit. We're going to assume that the ball leaves your foot at 10.3 meters per second. This would be to the left. So then this would have to go in as a negative value, and that would be the final velocity. So our initial is still 8.9, but now our final is negative 10.3, and the ball's in contact with your foot for 0.22 seconds. And we want to calculate the average acceleration. So then on part B, acceleration, change in velocity over change in time. Final velocity, negative 10.3 meters per second, minus the initial velocity, positive 8.9 meters per second, over our time period, 0.22 seconds. That's going to give us an acceleration value of negative 87.27 meters per second squared. Interpreting, our acceleration is 87.27 meters per second squared left. Now, part C. Considering part B, at what time between 0, when the ball first contacted your foot, and 0.22 seconds, when the ball left your foot traveling 10.3 meters per second, was the ball at rest? So now in part C, we want the time when the final velocity is equal to 0. So then acceleration is change in velocity over change in time. We're using the same interval as part B, so then our acceleration is still 87.27 meters per second squared left. So I'm going to put in a negative 87.27 meters per second squared for our acceleration. Our change in velocity, Well, it still started at 8.9, but now we want the time when the final is 0. So then final, 0 minus initial, the positive 8.9 meters per second squared, divided by the time period, that's our unknown. So then to solve down for this, I'm going to put this over 1, cross multiply. So then we're going to get negative 87.27 meters per second squared times delta t is equal to 8.9 meters per second. There shouldn't be a squared on that. Okay, and then we're going to divide the 87.27 to the other side. So then delta t will be 8.9 divided by the negative 87.27, which is going to give us a time period of 0.10 seconds. That's how much time has passed from the beginning until the ball has stopped in the midst of being kicked to the left at 10.3 meters per second. So again, in this problem, we listed out the given. We drew a diagram because that was helpful in organizing information. Write out the equations and plug in values. Ponder physics.